Alright, so in this video, I'm going to solve the equation x to the power of 8 is equal to 25 squared. So to solve this, I'm going to first rewrite this as x to the power of 4 times 2 is equal to 25 squared. And if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So x to the power of 4 times 2 is equal to x to the power of 4 to the power of 2, and this is equal to 25 squared. Now I'm going to subtract 25 squared on both sides. So these two cancel out, and I get x to the power of 4 to the power of 2 minus 25 to the power of 2 is equal to 0. And before we actually do this, I'm actually going to take the square root on both sides so I can cancel these 2's out. So I get x to the power of 4 minus 25 is equal to 0. Now from here, I'm going to rewrite this as x squared to the power of 2 minus 5 squared is equal to 0. So now I can use the formula a squared minus b squared is equal to a plus b times a minus b on this. So this turns into x squared plus 5 times x squared minus 5 is equal to 0. So I get two equations. X squared plus 5 equals 0, and x squared minus 5 equals 0. So for x squared minus 5 equals 0, I get x squared equals 5. If I take the square root on both sides, I get x is equal to positive or negative square root of 5. Now for x squared plus 5 equals 0, I can subtract 5 on both sides. So I get x squared is equal to negative 5. If I take the square root, I get x is equal to the square root of negative 5, which is equal to the square root of 5i. So these are my four solutions to this equation. Alright, so in this video, I'm going to be solving the equation 5 to the power of x is equal to 50. So to first start with this problem, let's test different values of x. So if x is 1, then I get 5 to the power of 1, which is equal to 5, and this is too low. Now if x equals 2, I get 5 to the power of 2, which is 25, and this again is too low. Now if x equals 3, then I have 5 to the power of 3, which is 125, and this is way too high. So we know that the value of x is going to be somewhere in between 2 and 3, meaning it's going to be a decimal. So how are we going to find the exact value of x? Well, to start, we're going to be using logarithms. So I'm going to take the log on both sides, so I get log 5 to the power of x is equal to log 50. And the reason I'm doing this is because logarithms come with a special property that state that if I have something in the form log a to the power of b, I can actually move the exponent b to the front, so this turns into b times log a. So in this case, I have log 5 to the power of x, and we can think of x as b, and I can move this x to the front, so now I get x times log 5 is equal to log 50. And now remember, we want to find the value of x, so all we have to do that is to get rid of this log 5 by dividing both sides by log 5. So now these two cancel out, and I get x is equal to log 50 over log 5. And now let's simplify this a little to get the exact decimal value. So log 50 is the same thing as log of 10 times 5. And another property of logarithms is that if I have something in the form log of a times b, this is equal to log a plus log b. So now this turns into log 10 plus log 5 over log 5, which is the same thing as log 10 over log 5 plus log 5 over log 5, which is just 1. And log 10 is also equal to 1. So I get x equals 1 over log 5 plus 1. So now all that's left to do is do 1 divided by log 5 in my calculator. So I get x is equal to 1.431 plus 1, which is equal to 2.431. So this is my answer.